Welcome back. Continuing from lecture 1, CSI30. We were talking about connectives, logical operators that are used to form new propositions from two or more existing propositions are called connectives. First connective we study is a conjunction. Let P and Q be propositions. The conjunction of P and Q denoted by P, notice this inverted VQ, right? That stands for and. P and Q is a proposition P and Q. The conjunction P and Q is true when both P and Q are true and is false otherwise. So you need both of them to be true for the conjunction to be true. Notice that in logic, but may be used instead of and. For instance, 2 is less than 10, but 2 is greater than negative 10. So that means 2 is less than 10 and 2 is greater than negative 10. Okay? Here is the truth table for conjunction of two propositions. P and Q are propositions and P and Q is the result of the conjunction of P and Q. If P is true and Q is true, both true, then the conjunction is true. If P is true, Q is false, then both are not true. So the conjunction is false. If P is false, Q is true, then both are not true. So the conjunction is false. If P is false and Q is false, then obviously conjunction is false because you need both of them to be true. Find the conjunction of the propositions. P, I am on the 1st Avenue, and Q, I am on the 34th Avenue. Well, let's figure this out. What this means is you're going to draw something, right? So you have two avenues. One avenue is this avenue. Okay? Now the other avenue is this avenue. Let's move this a bit. This avenue. Okay? So one is I am on the 1st Avenue. So that's your 1st Avenue. And the other is I'm on the 34th Street. All right. So this is 1st Avenue. This is 34th Street. So I am on, so these are the propositions. I am the 1st Avenue and I am on the 34th Avenue. So and means I am here as well as here. So I am here. So that's what and means intersection. All right. So and means intersection. So let's make that clear. All right. The second connective is disjunction. Let P and Q be propositions. The disjunction of P and Q, denoted by P, V, Q. V is for disjunction, upside down V is for conjunction. P, V, Q is the proposition P or Q. Or the disjunction P, V, Q or P or Q is false when both are false and true otherwise. What does that mean? You have to be true here or here, right? If you are false on both, well, then you are false. Okay. So or means you have at least one of them has to be true. So for example, so here is the truth table for disjunction. Propositions P, Q and the result P or Q. If they are both true, well, or says one or the other has to be true. So fantastic. It's true. P is true, Q is false. Well, one or the other is true. So it's true. F, T. Well, one or the other is true. So it's true. F, F. Well, neither one of them is true, so the result of the disjunction is a false. Now let's look at the disjunction of the propositions. I am on the First Avenue and Q is I am on the 34th Street. So let's remove the intersection. So now in this disjunction, I am here or here. So what's the picture? I could be anywhere on these two streets. Or means union. All right. Or means union. Okay. So union of states and so on and so forth. You know this, right? So and gives intersection, or gives union. I hope it's clear. All right. Now, exclusive or. Okay, before I forget, note that the disjunction corresponds to an inclusive or. Inclusive or means the commonality is included. When I say I will be on the First Avenue or the 34th Street, well, I could very well be on the intersection. Okay, that is an inclusive or. Whereas that is a disjunction is true when at least one of the two propositions. Now, what is an exclusive or? Let P and Q be propositions. The exclusive or of P and Q is denoted by P with an O plus. You see, there is a circle and a plus inside Q. This is the proposition that is true exactly when one of P and Q is true. So you are allowed to have only one true, not both true. Okay. So P and Q are propositions. P exclusive or Q is the result. If they are both true, the result is false. That's the meaning of exclusive or. Exclusive or, compare it with the inclusive or. Or is true if both are true. It doesn't have a problem with that. But exclusive or, if both are true, it's not okay for my exclusive or. Okay. If exactly one of them is true, the result is true. Otherwise, it's false. Okay. So, what is the exclusive or of the propositions? I'm on the First Avenue and I'm on the 34th Street. So let's remove that. Let's remove that. So this says exclusive or. That means I'm not allowed to be on the intersection. So I am on the First Avenue, or exclusive or I am on the 34th Street, but not both. So that is to be excluded, hence the name exclusive or. Okay, so let's write that down somewhere. So this is called exclusive or. Okay, means or but not both. Okay, so this or means all of it but not both. That is, you have to exclude the intersection, and that gives you exclusive or. Okay, I hope it's clear. Now, conditional statements. Let's go over these in our next video because it's a slightly new topic.